Hello and welcome back to another one of these foundation tier questions and grade 5 answers and all that fun stuff and walkthroughs and whatever. We'll just jump straight into it. We start off with probability and then some ratios. Probably the two worst topics, especially in foundation, but also in higher as well. So here I'm going to kind of break this down really nice and simply. So there are 3 red and 1 blue beads in a jar. So I'm literally just I like to literally draw them out, by the way. So we have 3 red, 1 blue. And it says, a bead is taken at random from the jar. What is the probability that the bead is blue? Now here's how it works with probability. Is the way you might word it is, for example, like 1 chance in 3, 1 chance in 4, something like that. What you want to do is we want the probability that it's blue. So we take the number of blues, which in this case there is one blue bead, and we do it out of the total number of beads, because we're saying that there is a 1 in 4 chance of me picking a blue bead. There is 1 blue bead out of 4 red, beads in total. So that's where that probability comes from. Now, definitely the harder part of the question is this. There are 4 yellows and 3 greens in a bag. So we have, I do actually have a yellow pencil. That's kind of yellow. 1, 2, 3, 4. And then we also have 1, 2, 3 greens. Sharon then puts more green counters into the bag such that the ratio of yellow to green is 2 to 5. So that ratio here of yellow to green, it means that for every 2 yellow beads, there are 5 green beads. Now, if you have a look, we have 4 yellow beads. So it's not exactly this ratio, right? There isn't 2 yellows and 5 greens. They're saying every time there's 2 yellows, there's another 5 greens. So in this case, for example, we could have 2 yellow, 5 greens. We could have 4 yellow and 10 greens. And we could have 6 yellow and 15 greens, and so on. It's a proportion. Now, since we have 4 yellows in this situation, then we needed to make the yellow number 4, because that's how many we have, right? We have 4 yellow beads. How many green beads are there if we have 4 yellows? Well, there's 10. So we can also add on the 10. So 4, 5, 6. In fact, it might make more sense to separate this, and I'll show you why in a second. So 6, 7, 8, 9, 10. So how many were added? Well, these were all added. And how many is that? That's 1, 2, 3, 4, 5, 6, 7. So 7 green beads were added. Oh, sorry, not beads, counters. I don't know why I kept saying beads. 7 green counters were added in order to make this ratio. Hopefully that makes sense. There are quite a few different ways to do this question. So we have point A has coordinates 40, 60 and point B has coordinates 0, 20. A straight line passes through A and B, and there's another point P that lies on the line. And the x coordinate is 0.5, find the y coordinate. Now we could find an equation of the line if we wanted to, and that would help. However, because they've got this kind of grid here, it kind of implies that we probably need to use the grid at some point. But if we do part A and draw the line, so what we're going to do is 0, 20. So 0 I'm definitely going to say is over here. And then how many squares do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's an odd number, literally and figuratively. And it goes up to 40. So we could go up in 5s. So 5, 10. Yeah, no, we can definitely fit 5s. 5, 10, 15, 20, 25, 30, 35, 40. Could we do another number? Maybe up in 4s. We could have gone up in 4s perhaps. Yeah, but let's leave it like this for now. The y coordinates have to go from 20 to 60. So probably 0 to 60 is probably the best way to do it, because we want to start from the correct number. I'm going to expect we go up in 5s again. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. So if we plot these 2 points, 0, 20, I want to plot them in black just to make it a bit easier to see. We have right over here. And then we have 40, 60. So 40 across and 60 up. And they're saying that there's a straight line going between them. So you would obviously use a ruler. I'm technically going to use a ruler by using the autocorrect feature. And it says the x-coordinate of P is 0.5. So it's like, it's all the way like back here. And all they want us to do is work out the y coordinates. So all we have to do is read off where that is roughly. So I would say roughly maybe like 21 or so. And that's it. That's all we had to do for that question. Now for part B, it does say, is it reliable? Explain your answer. And I would argue that it's not that reliable because the line we drew may not be accurate. So no, the line may be inaccurate. Generally speaking, if you're going to draw something by hand, it's not going to be perfectly accurate because it's by hand, right? So it's not going to be perfect. So as you can see here, like when I read this off, I couldn't see clearly what it was. So someone could argue that, oh, I think it's 22 or 21.5 or 20.5. And we'd all be correct because you can't read it off perfectly. So that's what we need to think about for part B. This is a pretty interesting question. So if Mr. and Mrs. Sharma are going to France, they each have £300, which they want to change into euros, and they say this deal. So either you get 1.04 euros for £1 on amounts less than £500. Not either. But you also get 1.12 euros for £1 when you change £500 or more. They want the best deal, so they're going to put their money together and they're going to change it into euros. But how much extra money do they actually get? So they know that putting it together will give them a better deal, but how much of a better deal is it? So if they did it separately, they're both going to do £300 separately, right? So if we say Mr. Sharma, in fact, if they do it separately, well, they're exchanging £300 into euros, and it says you get 1.04 euros for every £1. So in other words, £1 equals 1.04 euros. So if we're doing £300, all we need to do is do 1.04 times 300, which I'm going to do on a calculator. I think it's just going to be 312 though. 0.04 times 300, 312. So 300 times 1.04 equals 312 euros, which is this symbol, I think. Now, because they do it separately, they don't just have £300, they have 600. But remember, they're doing it separately. So if we times that by 2, that will add on Mr. and Mrs. Sharma's. So that's 624 euros. That's how much they get if they don't put their money together. So when they do it together, the wording is a bit misleading, but what you're going to do is when you change 600 or more, you're going to get 1.12 euros for every pound. So now our exchange rate is £1 equals 1.12. So if we're going to do 600, because again, there are £600 in total, right? We've got 300 for Mr. and 300 for Mrs. We're going to get 1.12 times, hello, there we are, 1.12 times 600, which gives us 672 euros. That's 672 euros. So the difference, extra money, so I could write extra, is just equal to 672 minus 624, which is 48 euros. You could convert that back into pounds if you want, but there's no need to, so I wouldn't personally bother. We've actually got one of the fatter foundation questions that I've actually come across. Like, look at this, 6 marker for a part B. Good lord. Okay, so Jane made almond biscuits, which she sold at a fair. She had 5 kg of butter, blah, 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 bunch of ingredients, cool. Here's a list for making 24 almond biscuits. And she made as many as she possibly could using the ingredients she had, work out how many she made. So what we need to do here is we need to work out how many biscuits she could make, given she had 5 kg of flour, 3 kg of butter, blah, blah, blah. So the way I would do it is I would work out how many batches each ingredient would let me make. Then we're going to pick the smallest number. The reason why I picked the smallest is because obviously if we don't have enough flour, then we can't make extra biscuits, or if we don't have enough almonds or whatever. So the way you do that is she has 5 kg of flour and each batch uses 150 grams. So what I'm going to do is I'm going to do 5 kg divided by 150 grams. Now remember, that's in kilograms, so that's going to be 5,000 divided by 150. 5, 1, 2, 3, divided by 150 gives me, so she could make 33 batches. You round down, because obviously you can't make a third of a batch. What on earth happened there? Did you see that? That was crazy. All right. The kg of butter, we're going to divide that by 100 grams. So that's 3,000 divided by 100 would be 30 batches. 2.5 kg divided by 75 grams. Okay, I've got a feeling that's going to be the biggest number, potentially. 2,500 divided by 75 gives me, again, 33 1/3. So at the moment, it's definitely going to be 30 batches. But 320 grams of almonds divided by 10 gives me 32 batches. So we picked the smallest number because the butter is the limiting ingredient. We can make 30 batches before we run out of butter. Without butter, we can't make any more biscuits. So she makes 30 batches. So each batch has 24 biscuits in it. So do 30 times 24, which gives us our answer, which is what, 720? Yep. She made 720 biscuits. That's kind of a lot. She's a bit of a psycho, but whatever. She sold 70% of the biscuits she made for 25p each. She sold the other 30% at 4 for 55p. The ingredients used cost her £45, and the total of all other costs is £27. Work out percentage profit. So, first of all, what I would do is write out the percentage profit equation. And by that I mean the percentage change equation. So if you want percentage change or profit or whatever, you take the new amount of money, so in other words, the amount she sold her biscuits for, minus all of her costs, divided by her costs, times by 100. Now the way I describe percentage change is I use this equation. New minus old over old. And the reason for that is, think about it, the new amount of money is however much she sold these biscuits for. The old amount of money is the money she put in to the business, or into making these biscuits. So in terms of the costs, we actually know that already. It's 45 plus 27, which is 72 pounds. Right, so we've got both the costs. We only need to know how much she sold them for, and this is how we're going to work it out. So she sold 70% of the biscuits for 25p each. So there are 720 biscuits in total. We just need to find 70%. So the way I would do that is I'd literally just do it on my calculator, 70% times 720, which would be 72 times 7 in total, but I'm not that much of a nerd. Shift times 720. Remember, that's the same as doing 0.7 times 720. But that's 504 biscuits at 25p each. Now, it does have the prices in pence, which makes sense for biscuits, but our costs are in pounds. So it might be a good idea to change it into pounds after we're done. So times by 25 for the number of pence each. Sorry, in total we got for this. 25. Wow, okay, so that's £126. That's kind of a lot. But wait, she also did 30% times 720, and that was at a rate of 4 for £55. So let's do it. So 30%, again, that's the same as doing 0.3, times 720 would give me 216. So she sold 216 biscuits, but she sold them at 4 for 55p. So what I'm going to do is to work out how many she sold, as in how many groups of 4 she sold. So you can imagine it like she's put these biscuits into bags of 4, like you get at Greggs or something, right? So she's put them in bags of 4 and she sold the bags. So how many bags did she make? Divided by 4, which would be 54, and then times it by the 55p. So in total, she has 54 packs of 4 biscuits, which is what this is, at 55p. Times it by 55 gives us the number. £29.70. So the total that she sold these all for is 126 plus, so 126 plus 29.70. She sold it for £155.70. That's an awful lot of effort just to... Anyways, so the percentage change would be 155.70 minus the cost, which was 72. I mean, she doubled her money, but like, that's a lot of effort for that. Equals, well, I don't know yet. Let's work it out. 155.70 0 minus 72 over 72, and then multiply that whole answer by 100, please. I might want to use brackets as well just to make sure my calculator doesn't do anything silly. And we get a profit of 116.25%, which, don't forget, and this is another thing they like to do, especially on just GCSE maths papers in general, is they like to sometimes give percentages that are bigger than 100, because some students have this idea that percentages can't be bigger than 100. They can be, okay? We can have that. What this means is she made, well, like I said, she over doubled her money. Doubling your money is a 100% profit. Anything more than that is more than doubling your money. So hopefully that makes a bit more sense. Ashton chooses 3 different whole numbers between 1 and 50. The first number is a prime number. The second number is 4 times the first number. God. The third number is 6 less than the second. The sum of the numbers is greater than 57. Find the 3 numbers. So, here's what I would do. And this is a really key thing here, is I would not bother using trial and error. Please, for the love of God, don't use trial and error. But I would probably use some kind of algebra to do this. So the first number is a prime number, let's call it x. The second number is 4 times the first, so it's 4x. And the third number is 6 less than the second, so it's 4x minus 6. The reason for this is it does kind of help us illustrate what this is going to be, or at least get a rough idea. But anyways, if I add all of those up, it should be bigger than 57. So x plus 4x minus 6 is greater than 57. So we get, no, not 6x, 9x minus 6 is greater than 57. So 9x is greater than 63. 63 is 7 times 9. So x has to be bigger than 7. Well, the interesting thing about that, so, okay, this is interesting because we could technically use this to get our value that's equal to 57. The other thing we should note is that the numbers are between 1 and 50. So, as it stands, if I sub the number 7 in, my 3 numbers are, respectively, 7, 28, God, and 22. Now, those numbers, 7 plus 22 is 29, plus 28 is 57. We want it to be greater than 57. Okay, well, this is quite simple. What is the next prime number after 7? 11. That makes this number 44, and this number 38. The interesting thing about this is the only combination that works. So you might think, well, why can't I just go to the next number? Well, look what happens when we go to the next prime number. We have 13. 4 times that is going to be 52. And if you notice, the numbers have to be between 1 and 50. So our only option, so these 3 numbers work, but they're not greater than 57. So we go to the next set of numbers it could be. Well, this one works because it is going to be bigger than 57 and it's less than 50 as in the individual numbers. And it can't be anything more than that because it would be greater than 50, as in one of these 3 numbers would be greater than 50. So our only option is 11, 44, and 38. So again, you don't need to use guessing, because otherwise you'd check like 2 first, then 3, then 5, then etc. But hopefully that makes a bit more sense how you can use algebra to work that stuff out. For our final question, we have a big fat 5 marker, which has a lot of information again. So Linda keeps chickens, of course she does. She sells the eggs that her chickens lay. She has 140 chickens and each chicken lays 6 eggs per week. Linda gives each chicken 100 grams of chicken feed, and the chicken feed costs £6.75 for a 25 kilo bag. Work out the cost of chicken feed for every 12 eggs. Okay. It's kind of a lot, I'm not going to lie. So here's what I would do. First things first, I would work out how many chickens how much feed she needs to give each chicken. As in the chickens in total, God. So, the total feed is equal to 100 grams times 140 chickens, which is going to give me 14,000. Yeah. is that grams? Yeah, grams of chicken feed, which is 14 kilos every single day. So, that's kind of a lot. It says, work out the cost for every 12 eggs. Each chicken lays 6 eggs per week. So I would probably make this into the total. So this is a total feed per day. Because we want to compare it to the number of eggs, right? That's what we kind of want to do in general. I would probably times this by 7 to get the weekly feed. That would probably be my strategy here, which would be 98 kilograms of feed per week. And the reason why I do that is because each week there are 6 eggs. So I can more easily compare it to the total cost of chicken feed for every 12 eggs. Okay, now for every 12 eggs. Well, what I would do here is I would then work out the cost for this 98 kilograms per week. So it's £6.75 for each bag. So she's going to need 4 bags, right? Because 25, 50, 75, 100. She needs 100 kilos because she only has 98 kilograms. So 4 bags costs 6.75 times 4, which is £27, right? God, you know, I'm too paranoid. I'm pretty sure it is. It is £27. Dang it. So it costs her £27 per week. That is for each of the 6 eggs. How many eggs are laid in a week? So we'll do 140 times 6. 140 multiplied by 6 gives me 840 eggs. And how many sets of 12 eggs is that? Well, if we do 840 divided by 12, actually, yeah, 840 divided by 12, let's do that. That would give me the number of 12 eggs, sets of 12 eggs. The number of dozens of eggs, how about that? That might be an easy way to put it. So that's 70 sets of 12 eggs each week. So what we're going to do is take this number and divide it by this number. So the cost per 12 eggs is the amount of feed she has to give every single week, £27, divided by the 70 sets of 12 eggs she gets. 27 divided by 70 is, let's call it, what, 39p? 38p? Yeah, let's say 39p per 12 eggs. Christ, that was a tricky question, especially in the wording. But again, hopefully it makes sense. We found out the total feed per week, the total cost per week for the feed. Then we worked out how many eggs are laid in a week. The reason why we've done it all in terms of weeks, by the way, is because the only information we get given is in terms of weeks. So it's easier to go from days to weeks than weeks to days. Otherwise, we'd have like 6/7 eggs a day. It's like that's really weird. You can't have 6/7 of an egg. So that's why I did that. Hope you found that useful. I believe we do have one more of these, so that should be quite interesting. But again, best of luck, and I'll see you in the next one.